Now let's see this question. This question came in GATE 2016 for 2 marks. Consider the following new order strategy for traversing a binary tree. Okay, so this is not a standard traversing strategy, but it is a customized way of traversing tree, in which it is given that let's say a new traversing strategy, new order is there, which does traversal something like this. Firstly visit the node, then visit the right subtree, and then visit the left subtree. Okay, this is the way in which this new order strategy is defined. Okay, we'll come back to it later. But what we have to do, that we have to firstly a particular expression is already given in terms of reverse Polish notation, which is basically what? Postfix notation. Okay, so there is another way of calling postfix notation reverse Polish notation. You can see also it is a postfix notation, right? Now what we have to do is that whatever the expression tree is there for this particular reverse Polish notation, so the corresponding expression tree which exists for this reverse Polish expression, we have to find the new order traversal of that. And what is the new order traversal? Which is defined in the way as in the given question. Okay, so firstly what we are going to do, we are firstly going to find the infix expression from this postfix expression, and once we have the infix expression, we can find the expression tree. And once we have the expression tree, then we will come back to this new strategy. Okay, firstly let's try to figure out what is the infix expression, so that we can find out expression this expression tree. Okay, so let's come back to this. This expression is there. This is a postfix expression, and from postfix we have to create infix, right? Okay, so how to do that? There is a fairly simple algorithm which does something like this, that we keep on taking tokens until it is a operator, and when it is an operator, we perform that in an infix way and push it back to the list. So my point is that 3 is there, 4 is there, and when an operator comes, then it will be written something like 3 star 4. This is the, then we will again see 5 is there, then again we see there is an operator, and once we get an operator, again we will perform the infix operation. So it will be something like this. Okay, now after that, after minus 2 is there, and then exponential operation is there, so it will be written like this. We have to do the infix operation something like this. There is an exponentiation 2. So this is what we are talking about. Okay, so this is there. Next, what is coming after exponentiation? 6 is coming, then 7 is coming, then multiplication is coming. So again operator is coming, so this will be written as 6 star 4, which is 6 into 4, 6 star 7, 6 into 7. Okay, so I will, instead of writing a new line, I will write it here only. Okay, so it will be 6 into 7. Okay, this is there. Then we are getting 1, then we are getting plus. Again we are getting an operator, which means that this plus operation is on the two arguments, this and this. 6 into 7 plus 1, so it means something like this: 6 into 7 plus 1, isn't it? Next, minus is there, which means that this entire expression and this entire expression, and there is a negation on that. So the final infix operation is something like this: 3 into 4 minus 5 exponentiation 2, and this is the left operator, operand, minus, this is going to be 6 into 7 plus 1. Okay, so this is the infix expression which we are talking about. Okay, now we have got an infix expression. It is fairly easy to draw our expression tree. So now we are going to draw our expression tree. Okay, so our expression tree will be what? Obviously the first is going to be this one, negation, and then it is going to be, firstly draw the right one because it is fairly easy, plus the right child is 1, then there is an exponentiation, multiplication 6 and 7. Okay, this is done. Now let's create nodes for this 3. So firstly exponentiation will be there, then right one is 2. Okay, for the left one we are firstly going to have minus, and then right one is 5, and the left one is 3 into 4, which is something like this, 3 and 4. Okay, so this is the expression tree. This is what? This is the expression tree for this infix and this reverse polish or postfix notation. Okay, now we have, so we can check also, see if we get a postfix traversal of this expression tree, then we should get this one, isn't it? See, 3. So how postfix will work? Firstly we have to pass the left subtree, then the right subtree, and finally we have to pass the root. If we do like that, then we should get this expression, given expression. Let's cross check. 3 4 star, correct. Then we are getting 5 minus 2 exponentiation, and then this entire left subtree is done. Then we are going to right. So after exponentiation we are going to 6 7 star, and then 1 plus, see, and then after this entire right subtree is done, then finally we are doing minus. Okay, so this expression is correct expression as per this expression tree. Okay, so once we have got that, then finally what we have to do? Finally we have to traverse it in a new strategy, in a new way, which is called new order strategy. This is given in the question as a new strategy, custom strategy, which is basically similar to our other strategies, but here slight changes there. It is like prefix only, but in prefix expression, firstly root is visited, and then left subtree is visited using that strategy, and then right subtree. Here something like prefix, but the difference is that after root we have to visit firstly the right subtree and then left subtree. So my point is that if a something expression tree is something like 6 7, then my point is that in prefix star 6 7, this is prefix, but as per our new strategy it is going to be the root first and then the right subtree. So it is going to be 7 and then left subtree 6. Okay, so in this style we have to traverse. Okay, so that style of traversal has to be done for this expression tree. Let's do that. I think it is going to be fairly simple, right? So see, it is going to be, firstly we have to visit root, then we have to visit right subtree. Now in order to do right subtree traversal, we have to do again this in the fashion of new order traversal. Okay, so this will also be done like that recursively. So in this also, firstly root will be there, and then right, and then left, and this left will be done again in that style, firstly root and then right and then left. Okay, now this right subtree is done. Now let's come back to this left. In left, what we are going to do? Firstly exponentiation, and then right, which is 2. Then we are focusing on this left subtree, which will be again firstly root and then right 5, and then this left, which will be again done like star, and then right one 4 and left one 3. So this is the entire new order strategy traversal, and that is what we have to find. Okay, so first one is minus, so definitely these two are not correct. In fact, we can see that this C1 is correct. Minus plus 1 and then multiplication 7 6 exponentiation 2 minus 5 star 4 3. Okay, so this we can see that this one is the exact one which we came up here. Okay, so our answer is C.